We've now walked through our 4 different basic operations in a MongoDB database. We have created records, read, updated, and destroyed, all 4 basic operations. We just finished up in particular with using the class-based update functions. We're going to move forward now onto some of the more complex examples or complex uses of these update functions. And so this is where we're going to start to learn a lot more about performance inside of MongoDB. First, to kind of frame this or kind of give you an idea of where we're trying to go, I want to add in a new property to our user model. Okay, so right now we currently only have a single prop in there called the name. That's all we have right now. I want to add in another property called the post count property. This post count property is going to be kind of help us pretend that we're making a blog post app of some sort. So maybe we have many users and each user has some number of blog posts. We'll store the number of blog posts that a user has as a simple integer on each user. So Joe might have 5 blog posts, Alex might have 1, Amanda might have 12. So everybody has probably a different post count. I want to first start by adding this post count property onto our schema for our user model. Remember, whenever we add a new property to a model, we have to update that model's schema. Our model schema sits inside of our project directory inside of the source folder. So I'm going to open up the user.js file, and inside of here we can find our current schema. I'm going to update the name, or excuse me, I'm not going to update name. Right after the name, I'm going to put on a post count, and this is going to be of type number. And I'll save this. And now really quick, I'm going to flip over to my terminal. You'll notice that in my terminal, all of my tests are still passing over here. So just because I add in a new property on my schema does not mean that any of my existing tests are going to start to fail. I can have as many properties on my schema here as I would like. Mongo just says, hey, this kind of really just tells Mongoose that this property might exist and what type it should be. So it's really just kind of helping us out. It is not really enforcing any requirements for the data that our model actually has. Not until we start adding some validations to our model and saying okay, I expect the user's post count to be a number greater than 0 or something like that. Would I expect to see some tests start to fail? Okay, so now we've got our post count here. Now I want to, again, remember we're trying to frame this whole discussion around these advanced updates that we might make using class-based updates. So I'm going to throw in a situation here. I'm going to say I want to write a new test inside of our update test file. So I'm going to flip over to update test. I'm going to scroll down to the bottom. And I'm going to say that I want to add a new test inside of here where we will try to just take a user and increment their post count. That's literally all I want to do. I just want to increment their post count by 1. So I'm going to write a test that says a user can have their post count incremented by 1. And then we'll add in our function after it, like so. Okay. Now you might be thinking, well, Stephen, hey, that's not hard, right? We've seen that set and save method where we can do something like joe.set post count, and maybe we'll set it to 1 or something like that. And then we can save it, and that's pretty much the whole ballgame, right? Well, again, specifically, I want to look at the class-based updates. So the class-based updates over here. So I want to be able to say, for this wide range of users, like maybe every user who has a name of Joe, or every user, period. I want every user, or this whole big group of users, to get 1 added to their post count. So rather than having an instance to a function, I want to use the class-based function to update a whole range of different users in one big go. Okay, so I'm going to take this out. Before we start writing any code, I want to flip back up to the top of this file, to our before each, where we define Joe at the top. And I'm going to give him a starting post count of 0. And I'm going to do this right here just to make sure that when we actually need to go and make an assertion inside of our test, we'll know that if we are incrementing our post count by 1, then our final post count should be equal to 1. Because we're starting at 0, we're going to increment by 1. 0 plus 1 is 1, which I'm sure you very well know. Okay, so basically at some point in time, we want to write a test in here that says something like assert that Joe has a post count of 1, right? 'Cause that's kind of like where we're headed. That's what we're trying to accomplish. So I want you to think, Using all the tools that we have right now that we've learned about making updates, how might we update every user, or maybe just like every user with the name of Joe, of which there could be very many, add 1 to each of their post count. So again, you might be thinking just like that set and save that we could do something like user.update name of Joe, and I want to now set their post count to 1. Well, this is a little bit of a trap right here. This will kind of lead you down the wrong path. This update right here that we're specifying, this is saying set every user's post count to 1. This is not incrementing by 1. It is setting their post count to 1. So if we had a whole bunch of users who had like a post count of 20 or 30 or 112, it would reset each of their post counts back down to 1. I could even make this test not behave exactly as we would expect by changing the starting post count up here to like about 20, right? Well, now when we do that update down at the bottom that I just added, we would be subtracting 19 instead of just adding 1. So the built-in update functionality doesn't quite work the way we would expect here for making a very small adjustment to a model. So clearly this functionality right here isn't going to work either. Okay, so clearly there must be some good solution, all right? There's got to be some solution to this. I just want to make sure it's really clear why we might go or not go down that particular path. So the next thing you might think would be, all right, Stephen, like, we get it. You want to update a whole bunch of different users. What if we do a find for every user who meets some criteria, like has a name of Joe, and then we'll iterate through each user. We'll look at their current post count, we'll increment it by 1, and then we'll save it. So this would be kind of a diagram of how that might work. We might say, hey, for every user inside of our collection, fetch it, load it up into our server, or for us, like our test suite, update the post count by 1, and then save the record back down to the database. Now this would definitely be a methodology that works, but there's one big problem with this. This means that for however many users we're trying to update, we're going to take all those users and we're going to load them up to our server. Any time that we can avoid loading data into our server from Mongo is a big win from us from a performance standpoint. So even though this approach right here would work, even though we could fetch all these users, increment some value, and then save it back to the database, we avoid this approach as much as possible because we always want to avoid actually saving any or actually loading any data to our server as much as possible. So instead, we're going to take a slightly different approach. All right, so this is finally, after laying out all these bad scenarios that you might try, this is the one that's actually going to work. So what we're going to do is we are going to use our server, or for us, like our test suite, to send an instruction to our Mongo database that is going to say, find these users, so like every user with the name of Joe, and update their post count by 1. Specifically, don't set their post count to 1, but increment their post count by 1. So unlike the example we were just looking at, where we could have been loading a bunch of users, making a modification, and then sending them back to Mongo, we are going to entirely rely upon Mongo to make these changes for us. So this whole discussion that we're having is opening the way to what we call Mongo update modifiers. And it's definitely one of the more challenging ideas or topics inside of Mongo. I'm going to pull up a little bit of documentation really quick inside my browser window. So here's Chrome, and I'm going to do a search for Mongo update, not operator, or yes, Mongo update operators. That's totally fine. So Mongo update operators, I'm going to click on the first link right here. This is a collection of what we call Mongo update modifiers. We can use these modifiers or operators in conjunction with the update function inside all of our different methods of updating a record. So this works not only with the update function on a class, we can also use it with find one and update, and also find by ID and update as well. It works with all of them. What these do is they allow us to send an instruction off to Mongo, and Mongo will execute that instruction for us inside the database. The reason that we use these operators is that they are fantastically efficient and performant compared to grabbing an entire record, loading up to our server, changing it in some fashion, and then sending it on back. So we can take a quick glance at some of the different modifiers or operators we have access to. First off, inc increments the value of the field by the specified amount. So this sounds an awful lot like the post count that we're trying to do. We can multiply the value of a field. We can rename a field. We can set the value of a field. This is another very useful one. We can unset a value. By the way, set right here, just to be really clear, this means like change the value of this field from whatever it is right now to this new value. We can specify an operator that will say only try to make an update if it's less than this existing value or greater than this value. And then we can also specify the current date in here as well. In practice, each of these operators are fantastically useful whenever you want to change a lot of different records in one go. So if you're ever updating just a single record, you don't really need to reach for these, but if you want to update like 5, 10, 15, 20 records all at once, you are going to want to start to reach for these update operators. Okay, so long discussion about update operators. Let's continue in the next section and figure out how we actually use them.